So first step, that's weird. There we go. I'm like, it's writing. Internet glitch. They've been having a lot of internet issues here lately. All right, so we've multiplied it out. Now we can do the derivative of it. So bring the exponent down and multiply, because that's the product rule or the power rule that we talked about. So 35x to the fourth plus 84x to the third plus 10x plus 15. And that's my derivative. Okay. Now, some problems are pretty easy just to FOIL them out or distribute them out to get the answer and come up with a way. Some are not going to be that easy. So we do need a rule to be able to deal with multiplication. If we looked at, let's just say I have f of x equals x to the third and g of x equals x squared. So if I had f times g of x, that'd be x to the third times x squared, right? If product rules work the exact same way as my addition and subtraction rules did, this would be 3x squared times 2x, which would be 6x to the third, correct? If I just did the derivative of each piece and multiplied it. So 3x would be 3x squared, that'd be x 2x, which would be 6x to the third. However, if I took those two and actually put them together, that would be x to the fifth, right? Which if I took the derivative of that, that's 5x to the fourth. Not the same thing. So as crazy as it's going to sound, that's literally what Leibniz did. He figured, oh, the rules are going to be the same. Back when he invented calculus, he was like, the rules are going to be the same. This will work. And then he started noticing problems like this and goes, wait, something's wrong. I got to come up with another rule. That worked. I'm not going to go through the proof of the rule. This is the rule. It's the derivative of the first times the second. So another way you can write this maybe a little bit easier is f prime times g plus f g prime. The derivative of the first times the second plus the derivative, or the first times the derivative of the second. So now if we take that fg of x, which was, what was it, x to the third, x squared. And let's use the product rule for it. So it's the derivative of the first, which is what? 3x squared, right? Times the second, which was just x squared, plus x to the third, times the derivative of the second one, which is 2x. So I have 3x to the fourth plus 2x to the fourth, which is 5x to the fourth. And that now works. Now, obviously, you're never going to do it on a problem that simple. You would just multiply them together to get it. But I wanted to show you that actually does work. Let's look at the first problem. So this was the first problem we did. Let's do this with the actual product. So f of x, or I'll use is the x squared plus 3x. So the derivative of that would be what? 2x plus 3. And then n of x would be 7x to the third plus 5. So the derivative of that would be what? 21x squared. Correct? All right. So it's the derivative of the first, so 2x plus 3 times the second, plus the first times the derivative of the second. And if we wanted to get it back to the way that your other one looked, we'd have to multiply it out. Plus 21x squared. Hold on. Something's wrong. Oh, I forgot a term here. No, that's there. Did I screw? Did we multiply this wrong? Or did I multiply this wrong? Hold on. Because I'm missing, should be x to the third, no x squared. Oh, that's 21x to the third. That's fine. So 42, it's still 78. Oh. Okay, let's try this again. 2x times 7x to the third, 14x to the fourth, 10x, 21x to the third, 15, plus 21x to the fourth, plus 63x squared. There we go, now we're better. 35x to the fourth, plus 84x to the third, plus 10x plus 15. Much better. Okay. Now, was that any faster? No, not necessarily. So one of the things, and this is why I said last week, or actually Monday or Tuesday, is that when you're looking at these processes, sometimes doing the algebra first is going to be easier to simplify the problem down and to get into a way that you can do that. Sometimes it's going to be easier to do other methods. Okay. Both methods will work and get you the right answer. It just depends on which way you want to do it. Okay? There is no right or wrong way to do it. Now, there are going to be some that are way easier to do this method than the other methods, but there is no right or wrong way to do it. Or there's going to be some like the ones we're going to do now that you can't do any other way. Let's do x e to the x. Like this. So what are the two things I'm multiplying in this? So it's x and e to the x, right? So if f of x is x, what's f prime of x? 1. And g of x is, so what's g prime of x? E to the x. So remember we have, so m prime of x is f prime times g, and then f times g prime. So f prime is 1 times g. F is x times g prime. It does help as you're starting off and working through it to do it this way and write it out. Okay. It does help to write down each term and do the derivative of each piece and then plug them into the formula. It is less little places that you can make a mistake while you're trying to do multiple things in your head at the same time. Okay. Again, we're starting off with really easy problems, just as you learned last time. Before the end of class, I will give you more complicated problems that you're going to have to do a lot of little steps for. So looking at it and doing the process out will help you a little bit better this way. So we multiply these out, we get e to the x plus x e to the x, which we could factor out the e to the x if we want, and have that. So either of those would be cool. It really just depends on what you're going to use the problem to go further with. Like in this case, we're not doing anything else. You could have left it like the first one. It would have been fine. You didn't have to factor it back out. However, if I wanted you to find me my second derivative, factoring it out is going to make your life a little bit easier than trying to do these pieces, because you still have to do the product rule here, plus you got that piece there. So. Let's do this one. All right, find me the derivative. All right, let's see. That's why I like to set two pieces. Because otherwise, it's big. Oh, did you just write all that? That's okay. I was gonna say, when I write the rule down, I'll see that. Yeah, that was the first thing I thought. This doesn't work. There's the rule. All right, as with all these problems, like I said, they can get overwhelming quickly. Okay, and the quotient rule is not much easier, but it's only going to ask you for a couple things. You're only going to either need to use what it is or the derivative of it, and then you're basically just plugging those pieces into the problem. So if you don't know where to start, just start by that, looking at each piece. So we're going to set f of x to be x plus just 2 square root of x, which I need to rewrite so I can get as an exponent from my square root. So then f prime of x, derivative of x is 1, and then plus 2 times 1/2 x to the negative 1/2. So 1 plus 1 over square root of x. Because the 2 times the 1/2 cancels each other out. And then remember the negative brings it down and we can rewrite it as a square root. If at any point I do a problem thing on the thing, I don't mind saying, hey, I don't know what you did there. And I'll just explain it or rewrite it out a little bit further. That's fine. I would rather that than you sit there being lost. E to the x is simple. The derivative of e to the x is e to the x. Okay, so now plug into my rule. I forgot, I crossed that off. So we'll call this m prime of x. So derivative of the first times the second plus the first times the derivative of the second. And I'm done. You can just leave it like that. Because and honestly, if you factor out the e to the x, it isn't making it much better. There's nothing you can put together with the other things. So, like I said, it's really dependent on what you're going to do after. Like if they ask you to do the second derivative of it, it might be easier to factor it out because then we have multiplication again. But in this situation, we're not doing anything else with it. It's fine to leave it like that. So. That's the quotient rule. If you notice, the top is exactly the same, except it's minus instead of plus. I make sure I write my product rule the same way as this one so that that stays the same. It'll always be the derivative of the first times the second, and then the first times the derivative of the second. Multiplication is addition, division, subtraction. The difference is here, I'm dividing by the second term squared. Or in this, basically the denominator squared. These are a little bit easier to split up because they're not next to each other. It's going to be the top and the bottom. So it's the numerator and the denominator, basically. Everybody got the rule down? Those are the only two rules we're doing tonight. See now all your rules. All right, so let's do this one. Same process. So actually, right there. So f is x squared plus x minus 2. So what's the derivative of f? Two x plus 1. G of x is x to the third plus 6. The derivative of g of x is what? 3x squared. So far, nothing's different than the multiplication rule. Same process. Find each piece, find the derivative of each piece. Now we just plug into the rule. So f prime is 2x plus 1 times g minus f times g prime all over g squared. This is one of those that you actually do want to work out just in case you possibly could cancel things out. There is that possibility that something on the top and the bottom can cancel each other out. So multiplying out the top and simplifying it down in this case is a good thing. So if we just look at the top, so we're just going to look at the top here. Because the bottom we're not going to multiply out because that's as simplified as you can get. So we have, let's see if I do this right this time, 2x to the fourth, 12x plus x to the third plus 6 minus 3x to the fourth plus 3x to the third minus 6x squared. So I've got negative x to the fourth, because that'll be a negative, and that'll be a positive. Minus 2x to the third minus 6x squared plus 12x plus 6. And that's what the book got, so I'm going to go with them right. So then we put it all back together. And unfortunately, in this case, there's nothing to be able to factor out or anything else. So that's bad. Oh, it's plus 6 Oxford. You're right. Plus. Good catch. Oh, you're fine. My mistake. I looked at that instead of the plus that I wrote above it. All right. Any questions? Make sense? All right. Your turn. Find me my derivative.
Oh,
Or actually, I'm sorry.
oh.
Yeah, absolutely. Okay. I said second, but she goes first. All over. That's good. Oh, you talking? So that's fine. Where do you go? That's okay. That's okay. Honestly, it's simple. Right, I know. Just change it to a minus and put it over. You're fine. All the work you did. Yeah, you have the slide, yeah. Good job. So most of you just left it like that, which is fine. This is one of those ones that, so actually, I forgot to spread there. First thing is I cannot cancel that and that, or that and that, because it's not multiplication. Okay. But on this one, actually, if you simplify the top down, you end up getting that, which in this case does not help you. But it was close enough to look like maybe it would. So it's always a good habit to get into to check those little things. But in this case, you can't cancel it out either way. So there's no issue there. All right. Okay. Now let me drive you nuts. Now it's the fun part of the night. Yeah. X minus 1 is not the same as 1 minus X.
Wait a minute. Since half of where half of two where that you get worse. X minus.
Oh, actually, in this case, you're right. It would have worked out that way. That's weird. Oh, I know why. Because basically you're switching both signs. So you're squaring a -1, which cancels itself out. So yes, that would have actually worked out fine in this case. So actually, really good. That's a great example. So when you do your test, your next test, and actually every test after this point, the first test, there really wasn't very much wiggle room in it. It was basically either right or wrong. Every test after this point, I will have the answer the way that I think the answer should be. If you come up with an answer that looks totally right in the steps, I basically just graph both answers and see if they come out to be the same. If both answers come out to be the same, you're good. In that situation, it would have been fine. So basically, I just checked to verify that your answer and my answer are equivalents. As long as they're equivalent, you're good. Because there is multiple ways to do some of these problems, as you're going to see in the next problem that I'm about to give you. So, good question. All right. Have fun. There's actually 3 different ways you can do this problem. I got to go back and look at the answers. I'm still wrong. I switched slides. So you have, how'd you get the 1? Oh, you did 1u, 1 over u times u. Okay. The derivative of 1 should be gone.
That's from this.
Oh, that's the mistake. It's u to the negative 1. That's the error. Okay. Then other than that, you actually, yeah, check your derivatives of those because you did the derivative without the negatives. Might as well just carry it with me.
I'm not sure what to do from here. Should I make them all have the same denominator?
I would put the ones that have the same denominator together.
Oh, well, yeah. That makes sense.
That and then that might clean it up a lot. No. Now I got to figure out what your mistake is. So you did the product rule. So that's that. That's fine. My guess, did you foil? That's what's the mistake. That's okay. Oh, okay. Then never mind. Keep going. Sorry, I thought that was your answer. Keep going. Okay. One shouldn't be there anymore. Shouldn't be a 1. Everything else is right. I know. Now where'd the u come from?
Oh, this one here.
Right. Yeah. Okay. Sorry. Keep going. Uh-huh. But wait, hold on. You didn't do your derivative right.
Would be -1.
Remember, that's u to the negative second, and that's u to the negative first.
Like 2 times u to the negative.
It'd be no, because you got to remember you're doing it with negative numbers. So it's going to be -2 u to the negative third.
Oh wait. Okay.
And you're doing quotient rule for putting them all together. I told you there's 3 different ways to do this problem. So far, I've seen all 3 ways. How'd you get 1?
That one?
Wait, that's 1 over u. How did it become a 1? Because that's not a derivative, that's just that, right? So the question is, how do you go from there to 1? I don't know either, so I can't help that. Do the derivative of that as a whole, but change them to negative exponents to make your life a little easier. Changing them to negative exponents will help. Okay. Don't change them back to this yet.
Pedantic?
1 over u. Oh, yeah, no. You have your bottom. Nope.
So this is keep track of that.
No, no, no. This isn't right. Something's up with that.
Okay.
That's right. Yep. Okay. Keep going. My thing stopped working, so I can't undo things. All right, I'll do that in a second. All right. So the correct answer is 1 over u squared, 2 over u third, 3 over u fourth. Yes. That's the final answer. How what? You could make it all have a common denominator. If you make it all have a common denominator, you actually would have gotten the answer that would look like if you did the quotient rule, where it would have had the bottom. Because if you did this part here and got a common denominator, and now I can undo that. How nice. You'd have had u squared. And on the bottom of a quotient would have been u to the fourth because u squared squared is u to the fourth. So it would have worked out to be the same. The book actually did this with the product rule. I actually think it probably would have been faster to multiply at the beginning and just do the power rule that we've been working with last time. So I would have changed this problem to, yeah, so that plus u squared, or u to the negative second, u plus u to the negative 1, and then multiply them together. So u times u to the negative 1 times u is 1, u to the negative second, plus u to the negative third. Oh, wait, sorry, not u to the negative third. That's 1. U to the negative 1 plus u to the negative third. Derivative of that is 0. The derivative of this would be negative 2u to the negative third plus -1 u to the -2nd, -3 u to the -4th, which ends up giving you -1 over u squared minus 2 over u to the 3rd minus 3 over u to the 4th. That's how I would have done. I wouldn't have. I probably wouldn't have marked it wrong. I might have taken off a point just because of the negative x1s and stuff like that. Tend to be a little more confusing. But I wouldn't have marked it whole wrong though. So, yeah, like I said, the book actually did it. If you had it already there, I would have just left it as 5. All right, I need to. What's going on with my keyboard? Allow me to use controls. I know. All right. Because I can't even copy and paste the next problem to give you guys. So we'll write the next problem and then I'll go restart my computer. Yeah, because nothing's working at the moment, right? Let's do. Let's do that. All right, write that problem down because I'm going to restart my computer in a second. Everybody got it done? Oh. Okay, it's working. Which you should have had for the two derivatives. Okay. So they distributed it through, and then they got a common denominator for the top, and then moved it to the bottom to get rid of the negative exponent. But this honestly wouldn't have been too bad, just leaving it like that, or even leaving it like this would have been fine. All right. Let's add a step.
Sorry, I was still
No. Yes.
a little confused.
Sure.
It's,
So they distributed that to get this.
I think I see how it's negative 2 figures.
Yep.
I'm just wondering how negative.
Wait. How this became this?
Yeah.
It didn't. Actually, it did. Because so on the bottom, they multiplied it by a t. So the numerator is not, the numerator has an extra t in there.
Oh, okay.
Yeah. Because they had to multiply the denominator by an extra t to get the 2, and then they added it to the top. That's where that 2t comes from. All right. So, extra step. We want to find the tangent line. So what do we need to do first before we find the tangent line? We need to find the derivative because we need to find the slope, right? So find my derivative of this one. The only thing they had a tendency to do is they put the bottom one first, but the derivative and everything else are the same. So this one should have been pretty straightforward to do the derivative of. Now, this is one of those cases on where you're going next depends on what you did. I want to find my slope at a specific point. So I'm looking at it at 0.1 So the x's value is 1. I wouldn't go through all the extra work to simplify this problem down, because all we're going to do is plug in 1 into x to find the actual specific value of the slope. Because we're looking for y prime of 1. So I could plug in the 1 just as easily here as if I did a whole bunch of extra steps to simplify it down. So do that here. So I have 2 times 2 minus 1 times 1 over 2 squared. The book actually did a whole bunch of extra steps to simplify it down. It's like, it's just as easy to do that. Does everybody understand why I plugged in the 1? That's the x value. That's what I'm looking for. So if we graph this, so I'm looking at the graph and I'm looking at the slope at that point. That's what I'm looking at. So when I found the derivative, I'm now going to plug in the 1 to find the actual slope value at that point. Does that make sense? And we got 3/4. The last part, they say they want the equation of the tangent line, right? So we got to plug it back into the point slope form of the equation to find my equation. So y minus y1 equals m x minus x1. So y minus 1/2 fourths x minus 1. That would be my tangent line. And remember, you can always use your graph to check. So if we look, that is the tangent line for that graph. All right, what do you want? What do you want more? What do you want another? I'm going to do 2 more problems. So what would you like a practice problem? Or I can just pick a hard one. Do you want another product rule? Do you want one where you have to decide what you want to use, or do you want one with a quotient? That doesn't happen. Even all of less algebra. Less algebra. Take a few minutes, look at it, see if you can figure out how to do it. And then I will go through and show you how to do it afterwards. remember this is the product rule one. So it's f prime times g plus f g prime. And we're looking at it at that line right there. Because that's 2. Huh? I don't know. I didn't do it. Hold on. Yep. I did that for too. What? Oh, I thought you were pointing at something. I thought you were pointing at something. I'm like, find those 4 things. That's the key. Find what f of 2 is, what g of 2 is, what f prime of 2 is, and what g prime of 2 is. Find those 4 things. The only one that you might have to do a little work for is g prime of 2. The other 3, you should be able to look at the graph and get those numbers with no actual legwork. At least first 2, you should definitely be able to look at it. What's f of 2? 3. Everybody see that? What's g of 2? 2. So that's just those points right there and there. What's the slope? Because remember, derivative is slope. What is the slope when f is 2? 0, because it's a horizontal line, right? If we look at how, hold on, so I don't erase my graph. If we look at how that line is right there at 2, it's the turn, right? It's the minimum point. So it's curved, but it's staying at that point. It is a 0. It is 0. 3, 2, 0. Now, at that point right there, we have to determine what the slope is, because now this one changes, right? But it's a linear equation. It's a linear line at that point, right? So we can just do rise over run. So up 2 over 4. So the slope is 1/2. Okay. Now we just plug into the formula. So P prime of X is 0 times 2 plus 3 times 1/2 x 2, which equals 3/2. See, no algebra. Yeah, but don't ever do that. Don't change an improper fraction to a mixed number, because next time you're going to have to go back to the improper fraction to do something else with it. 1.5 is fine. I would rather fractions over decimals, especially if they do not come up to be a straight decimal. So 1.5 is fine because it ends, and that's exact. If it was, say, 4/3, I'd want 4/3, not 1.3, because technically 1.3 is not right. And what ends up happening is a lot of times when you start using these things, you're going to have to use them in another step afterwards. And the more accurate your answer is at each step, the better you're going to get the final answer. So, all right, one more. I told you two. You want your last one to be. And he's regretting saying no algebra now.
No, I actually got that. I mean, I at least got 0 and 1/2. Plug it in.
Gotcha.
Give me more time.
What do you
I
want?
like looking at the picture.
Yeah. Pictures are nice sometimes. We're doing trig next week, so I'm not doing trig today. All right, we'll do this one then. All right, find me the equation of the tangent line. Be the last one. I actually had to look it up. Hold on. So this is the curve. Hold on. This is what the curve looks like. So it's actually a variety of problem graphs, but it's actually the curve at the top of a circle. So yeah, it keeps going down to 0. So basically it's, huh? So it's every one, those are different radiuses. So depending on the radius of the circle depends on where it actually goes up. This one is actually a radius of 1/2. So it was actually a curve discovered by Fermat, who also did Fermat's last theorem, which that one in that wonderful little book. He also studied a whole bunch of rabbits. But it doesn't give me why the specific name came up. Oh, because she was one of the first ones to publish it in an early book of calculus. And I'm going to go with at that point, a woman publishing a calculus book probably wasn't looked well upon in the late 1600s. So that name makes sense then. Yeah. They didn't like smart women back then. Some people have learned that lesson. Oh, boy. So that should be your derivative. It's always nice when there's a 1 on the top because things disappear really quickly. So now we're looking for at -1. So I've got 2 over 4, which is 1/2. One of the cool things about this graph is that oh, that actually is what I was just going to show you. Actually, that was literally what I was about to show you. Actually, one of the cool things about this graph is the slopes on the negative side are positive, and on the positive side are negative. It's literally symmetric. So if you were to actually graph that's actually what the graph is of the derivative of it. Yeah. I like slope intercept form. It's clean. Most times, and I'm very lenient on my answers because I'm one of those ones, like I said, it depends on what you're going to use it for afterwards. If you left it in point slope form, I'm not going to take off any points for it because it's right. It's not incorrect. If you left 2/4, I'm probably going to take off a point because you can reduce that to 1/2 and it's not 2/4, things like that. But I'm not so picky that I'm going to say this is wrong. I'm taking off points where it's not that big of a deal to me. I will tell you, there's other teachers that are very much like that, and they're like, nope, it's got to be this way, and that's it. I'm one of those ones that's like, I don't know what you're going to do with this later. So, all right, I will see you on Tuesday. I would totally practice your trig rules. I would totally make sure you remember your trig rules or what your trig functions are, like sine, cosine, tangent, cotangent, those things. So make sure you look up those before Tuesday.
Take care.
You too. See you next week. Oh, I don't want to do that yet.